All right. We'll let them judge that when I'm done. Mike Gehard, I've been around Boulder, 2010, used to run the group. Don't do a ton of Ruby today. I might show you some Ruby code today if you're lucky. But we're going to talk architecture. And I know the A word, some people get like twitches when we talk architecture, things like that. But this is a talk that I've given at a couple of conferences. I teach at a company called VMWare. I used to be at Pivotal. Pivotal got bought by VMware first of the year, so I'm now at VMware. We teach this to Fortune 500 developers as a way of paving the way to microservices. So, Andrew talked about this microservices architecture that really was a distributed monolith. If you ever find yourself in that situation, run screaming, because that is the worst place to be. Twitter, random stuff that goes up on the internet, mostly about mountain biking these days and going to Canada and riding bikes and drinking beer and whiskey. Every once in a while I talk about technology, so follow it, follow at your own risk. What else have I got open here? GitHub, some random stuff. There's a journey from monoliths to microservices, an interesting repo if you like this talk. That was the original version of this talk. And this is what I'm going to talk about. Anybody got a buzzword bingo card they want to try to win? So we're going to talk about the cloud. We're going to talk about architecture. We're going to talk about evolution. I cannot take credit for this talk. This talk was actually written by a friend of mine, my boss at VMware, has been my boss at VMware for a while, a guy named Mike Baranek. GNIP, now works at Pivotal/VMware. And that is the only slide you need to read. We'll see how this goes at the end of the talk. How many people like designing architectures and talking about architectures? How many people run screaming whenever the A word is used? Good. My biggest concern in the Agile world right now is we've thrown the baby out with the bathwater. We came from this world of big upfront architecture and ivory tower architects and things like that. We went the other direction. It's like, we don't need architecture. We're just going to write code as fast as we can, and we'll just figure it out as we go. This approach kind of ends up in the middle. This was why we use the word evolution for this architecture. It is not designed up. It's evolving, constantly evolving. And there are places along the way you can stop. And that's why I like it. I don't have to do all the thinking up front, but I also don't throw, I'm just not going to do architecture because anybody had been in a system without architecture. It's like, well, I changed something over here and something over here falls off the shelf. You're like, why is that? And we'll talk about high cohesion and loose coupling and all the buzzwords in architecture. Okay. How many people agree with that statement? All of your hands should be going in. If they're not, please raise them, because I will talk to your employer. So why is readability important for us? What? Oh. always one guy in the room. Job security, yes, because we don't have enough job security. Right, yeah, I'm the only one that knows this code. Nobody can fire me. Why is readability important? Some stat floating around the internet, 9 times more read than it is written, whatever it is. It's read a lot more. Why is adaptability important? Yeah, because I don't know what's going to happen with my business, especially if you work for a startup. You read the stories of how they pivot 6 times and whatnot. And even if you're not working for a startup, if you're working for a Fortune 500 company, like the companies I work with, like T-Mobile and Home Depot, you guys probably heard of these people. They're constantly having to change their software. So again, back to that analogy of I change code over here and something falls off the shelf over here. Why is that concerning as a software developer? We'll fix it. And also it's like, well, I don't want to make a change because I don't want that stuff falling off the shelf over there. Heaven forbid you're writing in JavaScript. Don't get me started on that one. So adaptability is important. I want to be able to change things quickly, because if I can't change things quickly, I can't add business value quickly. Why is extendability important? Ease of extendability. Eventually I'm going to scale. Kind of goes with adaptability as well. You know, I'm going to need to change software. Software is going to scale. How many people plan for scalability right out of the gate? Good. Please don't ever do that. You get, you know, oh, we're going to have to scale to 10,000 users. How many users you got today? 1,000. Okay, cool. Let's talk at 9,000 more users. The ability to extend the software to make it faster and change it is really important. Unfortunately, our software isn't like this most of the time. And these are the reasons why. So there are a couple of very poignant statements. This is one of them. Why is naming important? Clarity, readability, understanding, you know, the whole joke, you know, what are the two hardest things in science? Naming, cache invalidation, and off by one errors. So yeah, naming is hard. You know, we want to name things well so people could understand. We want to create mental models of our software. So that's important. Why is organization important? Andrew talked about the distributed monolith. Without organizing our code, you know, it can't find anything. You can't change anything. It's high cohesion, loose coupling. We've been talking about this for 25 years. Everybody know what a circular dependency is? Why are circular dependencies bad? They create coupling. So nobody in this room I worked with at Living Social. We spent some way too many months trying to extract a user service in Rails. We just gave up. And it's because Rails in the book always tells you has one and belongs to many. What have you just done? Circular dependency. Yeah. We'll kill you. Please stop doing that. Hopefully DHH watches this. And just lambaste me on Twitter or something like that. But yeah, those bidirectional associations are horrible for your code. And you're lucky if they're between two models. If you've got A depends on B and B depends on C and C depends on A, where's the circular dependency? It's a little harder to see. So by doing these three things, we argue that you could actually write much better software. And we'll talk a little bit about how that works. How many people understand legacy? When I say legacy to you, what does that mean? It makes money. Currently running software, not stuff I want to work on. Your art. So yeah, it used to be like Van Gogh had a legacy. He has paintings that people pay millions of dollars for. Legacy used to be a good thing. There is music that we still listen to today that was written in the 60s and the 70s. Then there's this guy. Gehard Fowler used to be my boss at Living Social, awesome human being, amazing musician. He plays the saxophone like nobody's business. Gave a really good talk at Go2 Chicago, I want to say like 3 or 4 years ago, on software legacy. And literally just says, like, when we hear legacy in software, everybody runs screaming. Why is that? Write crap code. Because we write crap code. We do. Like, I write crap code all the time. You ever go into Git? You're like, who wrote this line of code? You're like, oh crap, I did 2 weeks ago. But why is that? Right. Well, because we built crappy software. Because it's not changeable. Because, right. Exactly. Yeah, exactly. So, I mean, there's time constraints and all that stuff. That's why you should never call git blame. It should always be git who did this. Because you can't blame the human. They were operating under a certain set of constraints, and you don't know those constraints, and they were probably you 2 weeks ago. Great talk. If you can find it, I think it's called Software Legacy. If you do Chad Fowler, it'll come up. It's a really good talk. At the end of the day, you want to be kind to your future self. And those other humans that will, the old joke is like pretend the person who's going to read your code next is an axe murderer, and they know where you live. want to do. Like this is how software like evolves and stays flexible. So enough of me hold on, we got something in the chat. Oh, Andrew found the talk. All right. Thank you, Andrew. Cool. What was that? 6 years ago, Gehard gave that talk. Holy. Yeah, I'm getting old. Been doing this for years. So the next set of slides, we're actually going to go into enough of me ranting and more me talking about what we can actually do with our software. So, approach for building large software systems over time. You might be saying to yourself, well, my software's not big. Just wait. Anybody ever had that small piece of software never get big on them? Or that demo piece of software that was never supposed to go into production end up into production 4 years later? Yeah. Demo always ends up in production. It doesn't have to be large software. We tend to work with big companies, so that's why we talk about large software. But at the end of the day, stuff gets big. Hopefully stuff gets big. Stuff gets big, you're making money, and that's good. He changed these slides up on me the other day, so I'm a little behind. So we start out with a single application. Anybody writing Rails these days knows this can end up as a horrible train wreck. I mean, we've all been in those code bases. You've got active record models, you've got concerns, you've got God knows what's going on, like pre-commit, post-commit, after save, before save. You try to make sense of it, and you're like, I have no idea what's going on here. Why is that hard? Why is that bad if you can't create a mental model of what's going on in your software? If you can't understand it, you can't change it. Yeah, if you can't reason about what's happening, you can't logically change it. You can make a bunch of guesses, and then like the picture falls off the shelf over here. So then we got single application directories. So we're moving towards what? What are we adding to this software as we move from your left to right? Isolation, structure, themes. So you're organizing your software. High cohesion, loose coupling. You're going to hear those words a lot, that we talk about them all the time. A single application with components, and I'll talk about what components are in a little bit. And then look, okay, cool. I might have some workers that go in there. And then guess what? Anybody want to guess what that is? Starts with a micro, ends with services. Yeah. I really like microservices in very specific situations. Most of the time we're doing them wrong though. But notice it says different, not better. So DHH wrote a blog post about the majestic monolith. He talks a lot about this. There's a guy named Simon Brown on the internet, talks about well-structured monoliths. This talk is a lot of kind of that same information. We want to run screaming from monoliths because for so many years we've been writing steaming piles of crap. That doesn't have to be the case. We can write good monoliths. So this is actually really good here, and a lot of our code bases stop there. And then we'll go to microservices if we need to. Okay, so let's start with some code. This is going to be Java. Don't freak out because they have .java extensions on them. You're not going to be looking at any code anyway. You could do the same thing in Sinatra too. This could be a Sinatra application. Just add .rb on the end and put an app at the bottom. Typical first commit. I just drop everything in one directory. Why is that good? Fast. I'm moving, I'm understanding, I'm learning, I'm figuring out what my system's supposed to do. I have no time invested, lots of downsides though. What's a DAO? Does anybody know what that is? Is that the same as a persistor? Maybe. Yeah, who's to say? The naming is bad here. So obviously your code base stays here for all of like 16 minutes when you type Rails new. Lots of problems, but you're going fast, and if your startup dies after 16 minutes, great, you haven't like wasted any time. It happens. Okay, so how many Rails developers in the room? I'm going to rant on the Rails structure. I wrote a blog post about it. So we all, we drop our stuff into controllers, views, and models. And in this case, we're calling it controllers, data access, and models. Why is that bad? What does this application do? It's a Rails app or a web app. It actually has 3 domains. You wouldn't know that from that structure. And that's what Joel's talking about, is there's this idea of domains and business domains. That's why we write applications, not so we can write web applications. But we did this for like 10 years. This is every Java app you see from like late 90s to 2007 does this. Rails does this. So you've added organization, which is good. I've told you organization is good. You have clearer naming. Now we know that DAOs are DAOs, and we have models down there. But I think, who was it? Not Martin Fowler. Bob Martin gives a talk on architecture of the lost years, where he talks about this idea of you should be able to open up a directory and see what the domain of your app is. In this case, you can't. And because I'm talking about Java, I have a compiler. The compiler still allows circular dependencies. So if I had a user object, I can still do all kinds of crazy stuff. How to eliminate those later. Clear domain. So if I wanted to change the story domain, what is the minimum number of directories, the maximum number of directories I would have to go into to make a change for the story domain? 3. 8, because now I have to go look for all this stuff. That makes it hard to maintain and evolve. I'll make that argument, but we don't really give you a whole lot of background on that. So this is a friend of mine in Boulder. Would you put all your integers in one file? You're not doing a whole lot different when you drop all your controllers in one directory. You're organizing by function of the web framework, not your domain. So I'm going to talk about another way to do it. Everybody read Domain-Driven Design, the blue book, or the red book, or the other red book? No. One's green. Domain-Driven Design distilled is green. And that's the one you want to read because the rest of them are way too long. Yes, sir. You can totally grab it. They should be named the same. Well, but what I'm saying is you shouldn't break up by web framework concept. You should be breaking it up by business domain concept. But what I'm saying is you can still follow the MVC pattern. You invert it. Maybe some views. You can. I'm saying you don't. I'm not saying we want to go to microservices. We want good organization. We want multiple teams working in our code bases so we're not stepping on each other. I'm telling you that if you organize via this feature group, you will be better off in the long term. And this is one of those, just trust me on this. This is why I don't use Rails anymore, because Rails actually implements bad patterns. The active record pattern is the worst abomination, and yes, I said that. We can disagree all night long. One too many code bases where active record has caused me nothing but problems because I've linked everything to everything else. So I've been in code bases, Joel and I have been in a code base together that has overcome this. And I will actually show you a book that is written about how to overcome this in Rails based on 2 code bases that I've worked on for at least 1.5 years apiece. You can do it in Rails. And if you're doing it in Rails, awesome. I'm saying that most Rails code bases, more than 80%, do not follow those conventions. I've lost him. Totally. Saying the framework design. I'm saying the framework gives me bad patterns out of the box that allow me to write steaming piles of poo. I totally agree with you that I can work with the framework or against it to architect systems that are better. I'm saying if you choose a framework that doesn't force you into that pattern, you are actually ahead of the game. It's I want to see my domain mentality. It is a core principle, and I'm saying if you are writing large-scale software systems, you should be writing across domain. You should be organizing on domain boundaries, not architectural boundaries, not framework boundaries. You totally can. And I mean, like I said, a friend of mine wrote a whole book about it. So anybody that knows Stefan Hagemann wrote a whole book about this. Yeah. What does this give me? It gives me better organization. I will argue that I'm better organized because I only have one directory to go into and I want to change the timesheets component. That domain has got one directory in it. I don't have to go in there once. I will argue it's easier to read because I'm not grepping. I'm literally opening up a directory and I'm like, oh, look, there's my controller right up next to my data access object. So this could be your active record model. Again, I'm talking compilers at this point, so it still allows circular dependencies. I've switched over to statically typed languages, and that's a whole nother talk. But that's why we talk about compilers here. Because it still has circular dependencies, it's still hard to maintain. Okay, so how do I fix that? Anyone want to guess? You break the dependencies up into smaller boxes. So instead of dropping everything in one application, I create a components directory. So in Java, for those, anybody know Java in the room? What does a build.gradle mean? It means that directory can be built as a jar file. So I can use the compiler to enforce graph dependencies. By breaking this out into a components directory, I now tell it I'm building a jar. Anybody want to guess what this approach eliminates? Why does it eliminate circular dependencies? It's self-contained, and if I have a circular dependency between A and B, which one gets built first? The compiler will tell you that it can't do that. So you use the compiler. This is why I like compiled languages. I have another check. This is why I really don't like JavaScript, because it's the wild, wild. Sorry, you just happened to mention you use JavaScript. I'm sure there are other people in this room that use JavaScript. But I can use the compiler as another level to tell me when I've made mistakes, which I do all the time. I screw this up all the time. Breaking this into components, I'm now building jar files, distributable artifacts. And then my apps become a lot simpler. I disagree with this architecture in one way. I would not put my controllers in my components. I would put them in the applications. Anybody want to guess why that is? What is a controller? What is the job of a controller? The traffic cop. It translates between HTTP and my domain. So I would move those into the app, and I would have my components be simply business logic. I own all of that. So yeah, that's the one place I disagree with this architecture. So all these components now become reusable business logic, which is high cohesion, loose coupling. And I don't have any circular dependencies because I can't build those jar files if they're dependent on one another. It builds that stuff first, and then it builds all the rest of it. How do I break circular dependencies in a Rails code base? A Rubocop linter on anything that is a many association. That's awesome. I figured you guys would. Totally. 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 Yes, you are absolutely right. And I'm so glad that you guys have a linter rule, because that's how you, this is the problem with Rails, is as soon as you put in a has many, you've shot yourself in the foot. Because you created a circular dependency. Now, I will say there are places, times and places for circular dependencies. They are not across component boundaries. So if I want to ask for the timesheets for a user, who do I ask about timesheets for a user? Do I ask the user? Or do I ask the timesheets? How would you model that in a database? Right. How do you do that in most Rails code bases? User.timesheets. That's why everything is linked to users. This is why you can never extract user services, because user knows about everything. And yes, you can do this in Rails code bases. So guess what? How do I break out microservices? I just have another application, a bunch more application directories. The components directory doesn't change, I think. Yeah, there we go. So the components directory just moves over. Why did they just get to move over? Because they have no idea where they're being used. They're simply these little wrappers for business logic. Try that in a poorly architected, I will add that qualifier, poorly architected Rails code base, where you're like shifting stuff all over and you're copying and pasting and your diffs are like, dear God, what happened here? Yes, yes, yes. And so it's been interesting to see the industry in dynamically typed languages go to linters as another layer of compilation. You know, there's the whole, right, Haskell in the room. What's the old saying in Haskell? You should make illegal types unrepresentable in the type system. Why is that important? Because if your code's wrong, it won't even compile. I want to find those errors sooner and sooner in the process. So it's cool to see people who are writing dynamically typed languages use another layer to help them do that. You can do that in JavaScript all day long. And it's great to see people who are doing it, because this is how we get crappy code bases, is we don't do this and we just follow these random conventions. And it's great when you're writing the 5-minute blog, but when you're 4 years down the road and you're having to like pull this thing apart and it won't come because it's got all these dependencies on it, that's when things fall apart. So yeah, services are super easy. I just have a bunch of applications and these things all just get shuffled around. And now, because I have multiple applications, I can do other fun things with them. I can scale or tune them or introduce new people. I think people go to microservices way too fast. Way too fast. Oh, you want to have the multiple repo discussion now, do we? Yes, I'm still in one repository. I can build each one of these applications directories as a buildable artifact. And I can deploy them independently. I can build them independently because I'm using Gradle. Gradle will figure out what I need to build. and I can deploy them independently. So I have a microservices architecture. But I don't have to go here unless I need these two. This is where I feel like people jump the gun. They're like, well, I want it to be easy to maintain, so I'm going to go to microservices. And I'm like, nope. It's the opposite. It's the opposite. Because you haven't done this work. There's a great book by Sam Newman called Building Microservices. Really good book if you're looking for like why microservices. So now I have microservices. Now the problem is though, I've introduced some new downsides. So with microservices, I have costs. I now have new circular dependencies because I can now have dependencies between services, which gets interesting. You just get these cyclic dependencies through your services. And Andrew talked about it. That deploy where they had to like do 7 deployments in a certain order and they had to do some of them twice because of that. So you've got more costs there. Now you got to secure it and distribute transactions and API versioning. So I tend to like to stop at the previous architecture with one app and a bunch of components. So this is the book for those of you that want to read on how to do this in Rails. I don't get a cut of that. Stefan is a local Boulderite, good friend of mine, lives in town. He uses Rails engines for this. I'm not a huge fan of that because it's kind of a hack in the engine world. There's definitely some stuff you have to do, and he outlines it in the book of like these little tweaks you have to do to the engine to get it to work, but it works out pretty well. But if you're in like a Sinatra code base, just use gems. Just do separate gems. Don't put it all in the app. Here's DHH's talk, or his blog post. It's actually really good. One of the blog posts he's written that I actually mostly agree with. And then I don't know if this blog still exists because we got bought. But we've done this on 2 code bases. Both projects lasted over 1.5 years in Boulder. And while a lot of work up front allowed us to keep velocity pretty constant over the life of the application. All right, that's all you gotta do. It's simple. Any questions? And thank you for continuing to push back. It's so easy for me to get up here and be like, Rails sucks. So the question is on engines. Okay, so Elixir and Phoenix, not surprisingly. So there's different implementation. Not written Phoenix or Elixir. I'm interested in it. Engines were written for mountable applications in Rails. Stefan kind of hacks them a little bit, and I think there's some monkey patching that goes on. What you want, and which is one of the reasons I love like Java Spring, it's not going to come out of out of many people's heads that way. It doesn't enforce that, and I can just build jar files, and I just have this HTTP layer that I can plug into. Rails is awesome for getting things done really quickly, and when you want to deviate from that convention, you start smashing up against things. The code base that Joel and I worked in at Wonder did a really good job of doing this with service objects and all of this stuff, and we had a linter that made sure I didn't call out across service boundaries. But you're kind of like, you're working around the framework at that point. Yes. When you're using a lot, yeah, right. Yep. Yeah, by using convention over configuration, you gain a ton of upfront speed, but when you're talking 4 or 5 years down the road, I'm willing to give up that speed. If you're a startup, Ruby and Rails all day long, because you're trying to prove a business idea. You might not be around in 4 years, but if you're Home Depot, you're not going anywhere. So you're going to build all your apps this way using a JVM. I'm going to go a little bit more slowly at the beginning, use Java or Kotlin for those of you that are following JVM languages. It just is a little more, it's more configuration, but with Spring Boot now I get a lot of that stuff out of the box. So, I love Ruby. You know, I don't write a ton of Ruby and Rails these days, but it's still a good language if you're like kind of get something started. It just, you bump into these growing pains where you're like, oh man, I wish I could do this. And you can, but you end up monkey patching stuff and all that stuff. Oh yeah. Yeah, it's interesting. Yeah, I mean, a lot of dynamic language suffer from this. It's so interesting that Matt's is talking about putting a type checker into Ruby. I think people have realized that when our app skip, I give a whole talk on app structure and app, like why we pick statically typed languages. It's important, you know, and the analogies I gave a couple of gentlemen earlier is like, typically your apps start out like a tent. You're building them with aluminum poles and nylon. That's great till it gets to be 4 stories big. And you can't change the building materials because you've picked the language already. So you know what, I tend to pick statically typed languages because I like it's a little bit harder to build at the beginning, but when I go 4 stories, I've got the structure I need. So, and it's all about structure. So if you take anything away from this talk, is the more structure you can give your software earlier on, that's what architecture is, the better off you will be long term. And it's an insurance policy. You know, you're paying up front for a little bit less cost later. The downside being if you don't last that long, and that's what we get wrong, is we architect for the next 10 years. And we don't last that long, or the app falls over, the idea is no good. So it's all about adding structure. That's what you're trying to add in these code bases. Rylan.
Oh, I'm kind of bumping into this with a 4+ year-old code base that I have first commit on, so it's all my fault anyways. But I'm curious, you know, I have the Rails based components, but that's a hard pattern to refactor after the fact. What's the way forward to make it better? So I have domains, I have a folder, we're doing like some of that, but it's hard once you're like, I'm halfway there, 2 years in, and then it's like, oh, domains seem sweet, let's add it. And some good, and then it's also kind of hard to keep the organization going. And then what are the next steps?
Yeah, so refactoring to this is tricky. Because why is refactoring tricky? Open heart surgery. You've created this structure that you can't tease apart. You can't create seams. Software is all about seams, and if you create those things and you couple them so closely, you pull and half the app comes with it. So the key is to break those seams, to do what they do at GitHub. Literally a linter that says no more has manys. That could be 6 months worth of work. You know, as I said, when I was at Living Social, we worked for 6 months and just gave up. We're like, this is impossible, and just kind of went up. So it's pulling and then figuring out what moves and then figuring out how you can create those seams and being okay with like, it might be your life for the next month. Downside of that is if you have business owners that need functionality, like now you're having to do, these aren't refactorings. These are like open heart surgery. This is major restructuring of a code base at this point. And you know, you have to pay that price to get those seams. And that's why, you know, I harp on no has manys from the get. Because as soon as you add one of those, you've coupled 2 things together.
Oh, hey, chat people. Great. Yeah. So just as one example of like, all right, you have has-manys and you add destroys. What's the reverse of that, where you add some way to manage those orphaned database objects?
Yeah. So this is where I think Rails has done us a disservice, is it made us so easy for us to manage things that are hard. So I have this graph of objects that are all related to each other. In domain-driven design, they're called an aggregate root. And they all have to be created or destroyed at the same time. Rails has given these methods to make that look really easy. Everybody's seen Rich Hickey's talk, simple is not easy? I think he gives one earlier that's simple is not easy because he talks about complexing and stuff. In Rails, that is easy. It is a complex thing. So you just got to go delete them all, and then you've got to figure out some sort of database trigger or whatever to say, okay, when I delete this thing, this is one of the things I don't like about active record. So if you look at the active record pattern, has anybody read about the active record pattern in Martin Fowler's book, Patterns of Enterprise Architecture, I think is where it comes from? It was a pattern that was designed for very simple data access layers. There was another data access pattern called the repository pattern, actually written by our ex-CEO and another senior vice president, called the repository pattern. If I have the repository pattern, I can hide that complexity of deleting all of my children behind that. And that's where that business logic lives. But in active record, I've been given this way to interact with single objects and then create this graph where I can go delete things. This is one of the problems I have is the active record pattern. When you get to big, complex data access, it falls apart. And that's great for small things. But then, so what you end up doing is you end up having to write some sort of repository pattern. One of the code bases, those Rails code bases, we actually hid active record from the rest of the object model. We never leaked active record out of a layer. And it made some things really easy and some things almost impossible to do. I would say we're using the wrong pattern in Rails. We should be using a pattern that hides that aggregate root behind some sort of delete method that knows what all its children are. And then I go issue that, and then I have a SQL statement that just says go delete all of them. And maybe that's a database trigger. Maybe that's not a database. Another thing with Rails is we were taught that database triggers and cascading deletes in the database were a bad thing because active record would take care of that for us. That's okay. Like some of that stuff's okay to live in the database. It's just, it's not bad until it's great until it's not. And then you're like, oh God, what do I do now? That's a hard one because you've got all those hooks and things in Rails. Any other questions in the chat, Joel? No? This stuff is super interesting. Yes.
You've said a couple times that if you're starting out, then use Rails going quickly, but when you get to a certain point, you're going to hit all these problems and want to rewrite it. When do you make that, I guess?
I was just talking about this at the office yesterday. Startups are hard. What is the #1 goal of a startup when it starts up? Proof of concept, product market fit, as we call it in the biz. I need to prove that I actually have a market that I can serve and make money on. We were joking that what you should do is you can use Rails up to a point. And at some point, you either have to decide if you're going to rewrite the whole thing because the experiment worked. Like, hey, we're making money. A Big Bang rewrite's hard. They're really hard to get right. It's the whole second system syndrome from the mythical man month, I think is where that comes from. I think doing what GitHub has done a great job of, and I know this wasn't from the get-go. I know there's a lot of pain that's gone into this here because I have friends that work here. Just starting to implement these patterns, using linters, writing really solid Rails code bases from the get-go, or picking another language. Java's not a bad language. There's a language called Kotlin that I'm really hot on right now. That is, I think, probably what Scala should have been when Scala came out. Pick another language that you can go just as fast in. I can go just as fast in a Spring Boot Kotlin code base as I can in Rails these days. Hiring gets tricky. So if you're in a Rails code base, I would say pick some sane defaults, one of them being no has manys. Read up on some books on how people have architected large-scale systems, and then just try to do your best and know that you're going to trade some speed up front for possibly some pain down the road and just deal with it when you get it. That's another thing. When you start to feel pain in your code bases, you want to slow down and be like, oh, this is telling me something. This has gotten really hard. The problem is that now you got to go tell your business owner, oh yeah, that sprint we planned last week is going to be 2 weeks late because we've just smashed into this wall that we can't get. we'll just keep going. You have to be diligent and think about what you're doing and throw out some of the Rails conventions. No hooks, no active record lifecycle hooks. That's another one. I don't know if you guys have that rule too, Joel. No lifecycle hooks. Why is that a bad thing? Side effects, they're really hard to figure out. Like, I deleted this record. What the heck is happening here? What's going on? You can do that in other ways. You can write service objects. You can coordinate this stuff behind. There is no reason you shouldn't be writing plain Ruby objects in your Rails code base. Yes, it's no different than a hook. It's in the database though, so it's like it's swallowed in the database. Yes. Like, right. Right. I'm moving that into my application code. It is super coupled, but like SQL's a thing, and MySQL will take care of that. I'm not having to test my hook because I know if I have a cascade delete in MySQL, that's going to work. Like, I'm just going to assume that MySQL is going to take care of that. I don't have to write a test of like, oh, when I delete this thing, do those 7 records go away? My other problem with dynamically typed languages, I end up using my test suite as a compiler. So if you fat finger something in your code base, or so much of Rails is based on symbols. If you screw up one of those symbols, you got to write a test for it anyway. Like the database, if I try to create a trigger on a bad column, it just won't work. So I'll get that feedback earlier on. So yes, it is. I still have that coupling somewhere. I'm not getting rid of that coupling. I'm just moving it to a place where I know it's going to work and I don't have to test it, because it just won't compile it. Like the database will take care of it for me.
There's a certain factor when you abstract to the database. This is very important because I've actually battled this, and I do test triggers. I've tested the triggers. I've tested views. It's a pain in the ass. I mean, materialized views testing is a total pain in the ass. But that abstraction comes with, there's costs on both sides. So I'm curious as to when, say, advocating for 100% of the time, but is there a sweet spot that you find between, hey, this needs to go in here versus here, or vice versa?
I don't have a rule of thumb. Kent Beck once said, every good engineering decision should start with "it depends." It's so dependent on, do you have a DBA? If you got a DBA, let them write that stuff. And let them write, the less code I have to write, the better. Let the DBAs deal with it. So our applications are notoriously complex, and they're only getting more complex as we go into this world of all these things we want to do with them. I want to try to outsource that complexity as far away from my code as I can. I don't want to own any of that. Rails, the approach taken by Rails and many other frameworks, as you said, many developers don't even know about triggers in a database because they grew up in the Rails world and they've never learned about them. Rails took the approach is, I'm going to handle all of that logic in my business, in my application. It was really good at handling data. Stored procedures are a thing. Microsoft developers have been using them successfully for years. Java developers, I don't know why DHH made that decision. He did. But stored procedures are okay, but as you said, I've now moved that logic into a layer that can be really hard to test. Do I test it? Do I not test it? Do I run the risk that it's broken? How can I assert that it's not broken? Well, if I fat finger a column name, the database won't even take the trigger or this stored procedure. Materialized views, all of this stuff is super useful. You got to use it. And that complexity's got to go somewhere. I haven't met a framework yet that just doesn't make me think of that stuff. And I'm actually afraid of frameworks that hide that from me because it's great when it works. Anybody tried to debug active record? Oh, God help you. Yeah, and Aaron did a great job with Arrow. It's such a big improvement, but it's complex. And when it goes wrong, it goes horribly sideways. And if I'm owning that code, I got to go figure it out because someone's knocking down my door to fix the bug. So it's, Java doesn't make that any better. There's still complexity. Like, try debugging Spring JDBC template repositories. You write an interface and the compiler just generates a bunch of code for you. You're like, that's great, till it doesn't work. And now I'm like stepping through stack traces that are hundreds of layers deep that have like factory, data access factory, pattern factory in their name. And you're like, what does this thing do? Java's not any better. So yeah, I don't have a rule of thumb. I hate the word of rule of thumb because we're in a world now where it so much depends on what we're trying to do that, we could sit down and talk about it and I would tell you something and then I'd sit down with somebody else. And I tell my students this all the time. They're like, I want a rule of thumb. I was like, you can't use those words in my class. They don't exist because you just don't know. It depends. That's a quote I use all the time. Kent Beck said it. Every good engineering discussion starts with "it depends." I could stand up here and talk all night about this stuff. So yeah, please do feel free to grab me. Fun stuff. Like, this is cool architecture. This is writing good software. This is what we all need to be doing. And thank you for Ryland for owning the fact that 4 years later, you're like, oh, I created this mess for myself. Like, how do I get myself out of this? Like I said, I do this all the time with oh crap, I wrote that. What was I thinking? What was I doing? Yeah, it happens. What's funny is it happens to me in code bases where I'm the only committer. I was like, who wrote this? Oh, the only committer. Of course I wrote this. All right, yes.
You mentioned a resource for talking about circular dependencies. Was that book Domain-Driven Design, or was that another book?
So that was the Rails book that I put up here. If you're talking about breaking them in Rails code bases, it's this component-based Rails applications. In Java code bases, we just write jars and let the compiler figure it out because you can't have a cyclic graph in a compiled language. And by using Rails engines, you can create some of this because you start to create test suites that test those Rails engines, and you can use it. It's funny. I alluded to it, and I'm going to say it again. In dynamically typed interpreted languages, you end up using the test suite most of the time as another layer of compilation, because I have to assert that line has been run. Because not until that line is run do I know if I fat-fingered something, and I'm a horrible typer. I wrote a whole blog post on thought-driven development as I was learning Haskell and using the types, a very strong type system, literally write no tests. Anybody that knows at Pivotal Labs, like, not writing tests is blasphemy. I was like, I don't need tests because I have a type system. I can actually write these tests in other places. I don't have to write, integration tests. And most of the time, our integration tests are the ones that are our test suite, and that's why we have, hour and a half, 2 hour integration test suites in Rails code bases. But that's a really good book to break those. I did, because we've been talking so much about this, I wasn't going to do the sales pitch, but a bunch of us in Boulder have started this thing called the Continuum Collective. We love talking about this stuff. If you enjoy talking about this stuff, go to continuumcollective.io, not .org. That is a women's organization, and they're doing amazing work, but not the same Continuum Collective. And I think there's a mailing list at the bottom. But our goal is to build better software and talk about this stuff and help people do this stuff. It's kind of like the Agile Manifesto, but not at that level. So come check it out. We haven't done a whole lot with it yet, but we talk about it at Boulder in our office here. Yeah, for sure. We can get some folks to come in and talk.
Event or a chat, or what is it?
Now it is a loosely grouped group of humans. We're actually trying to start a business around this. So Ryan said, come and talk. We're actually trying to figure out how we can do weekends where we would teach you this stuff in an actual code base. It's called Cloud Native Weekends. But your best bet, do we actually have, oh no, he didn't get it up there. So this Cloud Native Weekend thing is the thing we're trying to like get off the ground as a little side hustle. Yeah, it's a group, right now it's a group of Boulder pivots that sit around and talk about this stuff at lunch. Was supposed to put up like an email link up here, but never got. So if you email sponsors at continuumcollective.io and said, hey, I'm interested in joining, it'll all end up in the same inbox. It is. Yeah. It's Agile Manifesto-ish, more around, I love this one. As you can tell, I have strong opinions based on successes of this. It's Agile Manifesto-like. We'd love to have people come join us. Like I said, it's us talking about this stuff at lunch, arguing. You thought this was a heated discussion? You should come to the office and hang out with some of the guys I work with. Holy cow, opinionated. Yeah. Well, thanks everybody.